welcome. My name is James Lewis. I'm going to be talking about building systems that are never done. So what does that mean? Actually, do you mind if we have the house lights up a little bit? Hooray, perfect, thank you very much. So I'll be talking about building systems that are never done. And never done obviously has a few meanings, right? The first one is this meaning. So incomplete. Building systems that are incomplete. Now, admittedly, as an industry, this is what we've traditionally done. We've built systems that are broken. We've built systems that don't work. We build systems that are incomplete in this sense. I'm not going to be talking about that sense, though. I'm going to be talking about building systems that are never done in the sense that they are never finished. We never finish building them. And I like this story to describe that. So there's an English author, fantasy author, called Terry Pratchett. He died, actually, earlier this year, which is very sad. He's my favorite author. He's written 60 books or something. I have them all. And in this book, The Fifth Elephant, he describes something called My Family's Axe. And if you can picture the scene, there's a dwarf king, and he's explaining to one of the other main characters about his family's axe. And this is what he says. He says, "This, my lord, is my family's axe." I'm going to paraphrase rather than read. "This is my family's axe. It's been in my family for 900 years. Of course, over time, we've changed the handle. Sometimes we've changed the blade, the head of the axe. Sometimes we've engraved the handle, then we've replaced it again, and we've replaced the blade. But even so, even if we've replaced all of the axe, 900 years later, is this not still my family's axe?" And that's really what I'm going to be talking about. I'm going to be talking about building systems that last. We might replace individual parts of them. Each individual part might be changed. But as a whole, the system persists. The system persists over time. And this is as opposed to the, I guess, traditional approach where we might, build something big and then throw it away and build something again. Maybe in 2 to 5 years we have to go back to our chief financial officers and say, "Hey, that 10 million euros we got given to build that system 5 years ago? Yeah, sorry. We need another 5 million or 10 million. Personally, I think we shouldn't be looking to build systems like that anymore. I think we should be looking to build systems composed of small parts that we can replace easily over time. Chad Fowler, I heard Chad Fowler do a talk recently, do a keynote, and he describes this as reclaiming the word legacy. He says we want to reclaim legacy so that it's a positive word, it has positive connotations. So not legacy in the sense of that we normally use it in software, which is, shall we say, very rarely positive. I mean, I haven't heard many developers say, "Yay, I'm just about to start work on a legacy project." All right, doesn't happen so much. But legacy in the sense of Mozart or Bach leaving a legacy, a positive legacy. We want to be building systems that we can leave as a legacy. And I quite like this idea. I suppose I should probably introduce myself first. So I'm James, I work for a company called ThoughtWorks, and it's awesome to be back in this city, actually, because for me, this city and this conference, or the precursor conference, are sort of at the heart of where my journey started into building sort of microservice-based systems, or at least where I started to talk about it. So I think it was 2012, I did a talk here called Java the Unix Way about a project I was on at the time with Sam Newman, who spoke yesterday. And we were talking about building this loyalty management system. But for me, the journey for microservices started probably the year before at a place called the Software Architecture Workshop. That's an interesting place because it sort of happens once a year, and a lot of people from different communities get together. So there were some people from the domain-driven design community, from the REST community, from sort of testing communities, from the B2D community, messaging, and so on. So Dan North, Gregor Hope, Jimmy Nielsen, Nicholas Nielsen. And during that workshop in 2011, we were talking a lot about how can we replace systems. The theme of that workshop almost became, I've got this big thing, I can't change it anymore, and I need to break it up. And from that came the sort of nascent idea of microservices style, which Sam and I implemented on a project, and then I came here and talked about. So I'm James. I still write code, incidentally. I don't just do this. I still write code. So building systems that are never done. This talk, in the abstract, this talk talks about things that have changed. So has design changed? Have the principles of design changed if we're going to be building systems composed of microservices? And that's what the rest of the talk is about. The talk is about the different tools and practices and principles we use as software developers, as engineers, as developers, to write code. So it's a bunch of tools, a bunch of practices, and I'll be talking through those in a minute. But I'd like to start by asking some rhetorical questions. So the first thing, this is my statement on what microservices should give us, right? Microservices, they should be cheap to replace. We should be able to scale them easily, and they should withstand failure. They should be able to do that. And the reason, apart from this nice idea of leaving a positive legacy or being never done, is that if we build systems this way, they allow us to go, quote from Adrian Cockcroft, as fast as possible. This is why Netflix went down this route in the first place, the unicorns. Adrian Cockcroft said, "We adopted a fine-grained, service-oriented architecture so that we could go as fast as possible." I'm often asked, why now? Why is it important, or why is this happening at the moment? Neil Ford, who's a colleague of mine, he describes the microservice style as the first post-DevOps architectural style. And what he means by that is a lot of the practices that we're using are really only possible now. So now that the DevOps culture has become deeply ingrained in many organizations, now that Amazon have popularized build it, run it, fix it, essentially. Now that we've got programmable infrastructure, software programmable networking, easy access to virtualization tools, easy access to containers. This is what Neil talks about. But there's another description that Dan North uses, and that's this one. Dan North describes microservices as replaceable component architectures. Again, in with this theme of building software that's never done. We want to be able to replace individual parts of our systems over time. In fact, Dan North is quite angry at the name microservices. He thinks it does it an injustice. Unfortunately, as soon as Martin Fowler names something, it pretty much stays named. So Dan lost out on this one. It's a time of really sort of great change in our industry. I'm sure a lot of people have sort of noticed this, all right? As well as microservices, there's a whole bunch of other things going on. And when you sort of look at the breadth of change and the pace of change over time, it's actually quite fascinating and in some ways quite scary. So this is a description from the 50s, a guy called John von Neumann. He describes something called the singularity. This is where the pace of technological change becomes infinitely fast, beyond which we can't really rationalize or extrapolate what the future of the human race might look like. Incidentally, this is captured by Stanislaw Ulam, who I believe is a fellow Pole. So Ulam talking with von Neumann, and they described this idea of the singularity. And it was interesting, and I bring this up because last year or 2 years ago, I was at a conference called GoTo in Aarhus, and the feedback from GoTo Aarhus was that none of the presenters seemed to have a clear idea or give clear guidance about what to do, about where software was going, about which are the right tools, which are the correct choices to make these days. It seemed that most of the presenters, these sort of industry experts, were kind of almost shrugging their shoulders and saying, yeah, I don't really know what's happening at the moment, which is a kind of scary thing. And as part of my work at ThoughtWorks, I'm a member of something called the Technology Advisory Board, and we produce something called the Technology Radar. And in that, I've noticed a trend over the last few years. A number of singularities have sort of approached and maybe even gone. So the first one is, we're probably all familiar with this, the JavaScript singularity. You can't walk past a, quote, front-end developer without 8 MVVM or MVC libraries falling out their pockets, right? But there's also a whole other set. There's things like, log aggregation singularity, the container singularity, this massive explosion in new techniques, new principles, new tools, which is really exciting and fantastic for all of our CVs, right? We just, we're using the Elk stack, we're using Logstash, we're using name a MVVM tool. So there's this rapid pace of change in our industry, which is only increasing. And actually even closer to home, even closer to my day job as a sort of coding architect, there's a whole bunch of things that are accelerating as well. So we're designing software very differently. We're thinking about breaking software up into smaller parts, smaller composable parts. So Martin Farrell and myself authored this paper on microservices a 2 years ago nearly now. And in this, we were describing, or attempting to describe, the characteristics that we'd seen teams apply. We're trying to extract a set of characteristics to describe this new style of writing software. I want to be very clear, we weren't trying to define what microservices are. All we were trying to do is identify a whole number of characteristics, a set of characteristics that we extracted from teams. So they were ThoughtWorks teams, they were industry-wide, so the Netflixes, the Twitters, and so on. And from banking and other domains. And this is, I think, we were quite pleased. This is a fairly good attempt, I think, at characterizing what microservices are. Obviously, there's been a lot of work done more recently to sort of firm some of this stuff up. And I've been applying a lot of these characteristics myself, so decentralized governance, building out small services. And there's some things that come up time and time again as being really, really difficult to do. So I'm just going to explain some of these and why I think they're really, really hard. The first one, as we can see, is end-to-end testing. Now this is, automated testing as part of a continuous delivery pipeline, and automated product testing where we bring a whole bunch bring all of our software together into one sort of integration environment, say, and run end-to-end tests against it. And this has been a sort of core tenet of how we verify that our software behaves as we expect, and also how, as a developer, I get fast feedback as to whether I've broken something. It's end-to-end testing. Turns out this is hard when you're building microservices. The next thing is deploying the parts of the microservices independently. Right? So we've designed our system, we've built our system out, and it's got all these interchangeable, sort of replaceable moving components, the microservices. We want to be able to deploy them on their own. Turns out that's actually quite hard as well, relating to the end-to-end testing thing. If we just push something out into production, how do we know it's not going to break all its dependencies? Or how do we know if it's a dependency of other services, they're not going to break? This is quite a tricky problem. And the final thing is service versioning. How do we version microservices? How do we ensure that we can evolve them independently over time? What we want to be able to do is replace them, scale them, all these things. But if we've got 2 applications, this becomes quite tricky. If we've got 100 or 600 microservices, or in some cases, I believe, PayPal are in the couple of thousand mark, how do we actually, how do we test, how do we deploy, how do we integrate our software? I think it's probably worth explaining a bit about why this is so hard. So the first thing with testing, as I say, as developers, we're into this idea of continuous delivery. We want to get fast feedback before our software gets into production. We want to know whether we've broken anything, we've changed the behavior of the applications we're writing, right? But the problem is when you've got dependencies between individual components, we'll change one, and then we want to make sure it's still working with the other one. And one of the tools we're using at the moment with microservices is, or rather that is being extensively used, is the idea of using fakes. So this is what I mean by, or this is what I'm going to explain as, the sort of end of end-to-end testing. There is a movement, not everywhere, but in lots of organizations, away from the idea that we'll put everything we've got into an integration environment and then execute some tests against it. Maybe they're acceptance tests, user journey tests, whatever they are. Instead, we want to be able to test these things on their own in isolation from one another. And in general, what we've been doing, and what I've seen teams doing over time, is changing from using real concrete dependencies to using faked out or stubbed out dependencies. So this is fine. This allows us to test our services on their own in isolation, but it does mean that we don't know how how the system application as a whole works. The other thing that's quite tricky is integration. Integrating microservices, as I said, is pretty tricky. And the reason, if you think a little bit about it, is probably quite obvious. We're used to having a build pipeline, right? So I write some code, I commit, it goes into some version control system. There's probably a build server monitoring that for changes. When something changes, something gets, it pulls out the code, compiles it, probably if it needs compiling. Maybe we'll run some unit tests, and then after that we'll push it onto the next stage of the pipeline. Maybe a jar file is built or an executable is built, and then some more tests are run, maybe some functional tests, and after that maybe some integration tests. After that we'll push into UAT, and after that we'll push into production. This is a fairly standard build pipeline, and if you've got a single application, that's nice and simple. The problem comes when you've got lots of these applications, because you end up with lots of independent build pipelines, right? Owned by, potentially, many different teams, certainly many different developers. And if you think about it, I'll make a change in one service, my colleague makes a change in another service, and both of these changes start progressing through their build pipelines. And they get to the point where they need to be tested together if they have a dependency. So what do we do at that point? Well, generally, we'll fan in a set of build pipelines into some form of integration test environment, some integration environment. So we'll fan into some integration tests before pushing on to production. And that's kind of okay for one, and maybe it's okay for two. But then when you get to 3, 4, 5, 6, you start to hit the problem, this kind of combinatorial explosion of complexity. How do we manage to test all the different versions of our application together? Often in production we'll have a set of versions, and I'm upgrading one of them. So do I test that version against all the production versions of its dependencies? That sounds like a reasonable idea. It's what we would normally do. So we'll have an integration environment with production versions and the new version of a single service. That's fine until you get to the next service. Do you have another integration environment for the same? And as I say, all of these are changing all at once. So do we have an integration environment for both production and snapshot versions of each of our individual services? In the situation when you have 10 different pipelines, potentially you might have many integration environments. That's not a sustainable approach. But it's kind of okay, because there's a whole bunch of people, a whole bunch of teams who've been exploring slightly different approaches to integration, different approaches to end-to-end testing. And I'll talk about those a bit later. Incidentally, basically I'm saying we don't do integration tests anymore. So if you're a bit bored, you can kind of leave now. And, oh, there are some people. No more integration tests. But this got me thinking about what else is changing. So end-to-end testing is going to become difficult. You know, integration environments, product-level testing becomes difficult. What else as developers is changing now that we're building replaceable component architectures or microservice-based architectures? And you know, I put my thinking cap on, had to think about this, because you know we've become used over time to relying on a massive toolkit, huge toolkit. And I was thinking, can we still rely on this toolkit? These are maybe some of the techniques we might be familiar with, right? So we've got the Gang of Four patterns, we've got Dry, we've got Yagni, we've got emergent design, things like extreme programming. All these tools and practices that we've come to rely on to build robust software that we can get into production, verified, we'll get fast feedback along the way. Are these tools still valid? Can we still use test-driven development, for example? And that's really what the rest of the talk is about, looking at the toolkit that we have as software developers and trying to understand whether those things apply building microservices. When I was thinking about this, I was chatting with a guy called Russ Olsen. Now, Russ is awesome. He did a great keynote at QCon in London called To the Moon. I suggest you seek it out if you can. It's about the story of the Apollo moon landing. And whilst we were talking, he mentioned this pretty crazy thing that happened during the Apollo program. So people are unaware of the Apollo program. Essentially what happened was, NASA were told by JFK that they were going to send a man to the moon within a decade, and I'm pretty sure that the people at NASA went, "What, really? That's pretty crazy." But nonetheless, the project was started, and they did this interesting thing. They did essentially something called concurrent set-based engineering. It turns out the way you go to the moon is not by starting off building a giant Saturn V rocket with the Apollo capsule on the top. You start out building smaller spacecraft. You test out individual parts of it. So they started by building out something like the Gemini modules and things like this. And NASA at the time was composed of a bunch of people who were essentially pilots and aeronautical engineers. That's what NASA was. And so they came up with this mechanism for landing someone, returning someone to Earth from space that looked like this. And this is true. So this is the Rogallo wing from the Gemini project. And essentially it's a hang glider. So originally, the space capsules were going to be, they'd re-enter the Earth's atmosphere, the heat shield first, and then they'd flip, and hang glider wings would fly out, and they'd kind of glide down to land. And they built some of these, and actually they landed one of them. But then a funny thing happened. A project manager turned up, a new project manager, and he sort of looked at these plans, and he sort of looked at the folk at NASA who'd been working on them, and he basically said, "You're all mad. You're all completely insane. Why don't we just drop this thing into the ocean on a big set of parachutes?" And that's kind of what happened. And I was thinking about this story as Russ told me, and I thought that's kind of interesting, because what's happening there is someone from outside is coming in and looking at a slightly different level of abstraction at the problems that people were trying to solve. So maybe that's what I'm going to do today for the rest of the morning. of my session is to look at the different tools and practices from the perspective of microservices, rather than from the perspective that we might be familiar with of in the code. Because I kind of realized over a period of time, maybe the last couple of years, that essentially all the practices and tools and the toolkits that we have, we can apply these, or a lot of these tools, apart from end-to-end testing and integration environments, all the way up and down. So the first thing I'm going to talk about is one of our old favorites, which is Yagni. Can I have a show of hands? Who's come across Yagni? Actually, not so many people, unless you're all, maybe you're all asleep. So Yagni stands for you aren't going to need it, you ain't going to need it. And it's a sort of a mantra in extreme programming, right, which exhorts us not to write more code than we need to. It's closely linked with test-driven development. This gives us a nice approach for minimizing the amount of code we write. Right? You only write the code that satisfies tests. So you aren't going to need it. It's also related, Martin talks about this in an article recently, Martin Fowler. He identifies 4 types of waste, or 4 types of costs associated with us writing software we don't need. Yagni. My first introduction was in ThoughtWorks London when I was learning test-driven development, and a colleague of mine at the time, Sydney, he used to literally slap my hand every time you'd even introduce a variable that you didn't use. Because this increases the cost of carry of your software. Over time, that just single unused variable or single not needed variable becomes 5 unneeded variables across many, many classes. And then people are, another developer will come along and think, I'll just use this for a particular purpose, or I'll just access it directly. Essentially, it's the beginnings of a big ball of mud. So Yagni, really important. And I was thinking about how this applies to microservices. And my approach to building out microservices is to follow a sort of emergent approach. Right? Start with one thing. Start with potentially something that could look or grow into a monolith. And as you need to, split services out. So as you understand about the domain, as you understand what the bounded contexts are within your domain, what the varied subdomains, in domain-driven design terms, you separate these out into services. But you don't do it until you've got an idea of what those things should look like. You don't just go off building microservices for the sake of it. You build them out as you need it. You allow them to evolve and emerge over time. And so I was thinking, yeah, Yagni, that kind of makes sense in the sense of microservices. The next thing, and I'll ask for another show of hands. Sorry to make you should be lucky. Sometimes I ask everyone to stand up. The next one I want to talk about is grasp. So who's come across grasp? Yes, we've got a couple. Hardly any. So grasp is pretty old. Oh, I've gone past it. Grasp is pretty old. And it was, I think, defined by a guy called Craig Larman. And GRASP stands for General Responsibility and Assignment in Software Patterns. And from these we get a couple of old favorites, like Information Expert. We get the idea of loose coupling and high cohesion. These are GRASP patterns. And I was thinking about GRASP and whether that applies. And this is a story from a client I was visiting. They had 2 teams, one team in London, one team in India. And the interesting thing about these 2 teams is they were split according to bounded context, according to domain. So the team in India were building one thing, one domain, and the team in London were building another. And essentially one side was building out a retail site, one side was building out fulfillment. They're kind of like a travel site. So you book travel with them. And essentially, they have a website you can go to buy stuff, and then they have then they have another piece of software that sends you tickets, retail and fulfillment. And it ended up being quite a nice architecture, because they ended up with these 2 very distinct bounded contexts, separated by this bus, and messages would pass between them. And this is something, when we're building out microservices, that we should aim for, right? We should aim for completely distinct, bounded contexts, very loosely coupled, highly cohesive, and specifically highly cohesive around business domains. What I've been used to for a long time is being cohesive and separating concerns along technical boundaries. Right? So we separate concerns around things like, presentation and data access. So we'll have our presentation layer and our data access layer, and they're really nicely cohesive and they're really nicely decoupled from a tech perspective, from a technical perspective. Unfortunately, what tends to happen if you separate around technical boundaries is that you're coupled from a business perspective. If I want to make a change in one part of my a business domain, I often have to touch many, many, many different parts, many, many, many different layers, and possibly deploy them. So when we talk about microservices, we always sort of say, you organize these things into bounded context around your business. The separation of concerns should be around the business, rather than around technology. But yes, these patterns from GRASP still apply, and in fact are something we should be striving for. High cohesion and low coupling. So the next thing I'm going to talk about is something that, again, that's pretty close to my heart, and that's DRY, don't repeat yourself. Show of hands for DRY. Come on, everyone must have come across don't repeat yourself. Thank you very much. So dry. Do we write dry code still? This is the definition, or a definition, from Prague Dave Thomas. And that definition says, every piece of knowledge must have a single, unambiguous, authoritative representation within the system. And that, he goes on to say, or it goes on to explain that this includes things like your build. Your build should have a single, should be dry. Your test should be dry, etc. And I was thinking again, does this apply when we're building out services? Now, the problem with dry across services mainly are to do with shared dependencies. Because the temptation is, for me certainly, and this is something I've fallen into far too many times, is to think, right, I've got some code over here, I've got some code over here, and it looks the same. Therefore, what I'm going to do is I'm going to follow the dry principle. I'm going to extract that. This is reuse. This is what our enterprise architects tell us is awesome. Reuse. I'll extract that code out into a shared jar or a shared DLL. Maybe I'll stick it into a Maven repository somewhere. Maybe I'll stick it into NuGet, some kind of package management, and then all my services can access this shared dependency, which sounds fantastic, right up until the point it's not fantastic. And the problem, essentially, is that you limit the rate of change of each of these independent microservices. They suddenly become tightly coupled to this shared binary. And every time you change that shared binary, you then have to, unless you're really, really careful, change all the services that use it. So a change in one of the dependencies, one of these binary dependencies, means a ripple effect, where you have to deploy all your services. So dry, removing duplication in domain code across services, for me, is a frankly bloody awful idea. That doesn't mean to say that you shouldn't be dry within services. And that doesn't mean to say that you shouldn't extract any dependencies and share code. But for me, I think the only code that we should extract and share is the real sort of infrastructure code. Things like how we do monitoring around here, shared metrics libraries, how we do log aggregation, how we talk over HTTP. Those sort of real technical dependencies, or those real sort of technical concerns, are kind of ripe for extraction into shared binaries and shared around between services. But as soon as you start extracting domain code, you end up in all sorts of problems. One approach to addressing this is the idea of service templates. So you can extract a service template, maybe something a bit like Spring Boot or Drop Wizard, but specifically a domain-specific service template. So the ability, and then put it in GitHub, say. And what that allows you to do is really easily spin up new services that look like services that already exist. So this is where you do things like bake in how we monitor our code, how we check it's healthy, check our services are healthy, and so on. So the sort of the shared monitoring, logging, cross-functional things can go into a service template. So, as far as dry goes, my personal advice would be don't repeat yourself within services, but it's okay to duplicate, and preferable to duplicate domain code across services. It's almost a restatement of domain-driven design anyway. So now on to a controversial one. TDD, test-driven development. I won't ask who's heard of test-driven development, it would be pointless. I could ask who hasn't heard of test-driven development, it might be better. So, I first learned TDD probably about 12 years ago now. I was very lucky working at ThoughtWorks at the time. They were very sort of skilled practitioners of test-driven development even back then. TDD, essentially means that we end up writing unit or acceptance tests according to this kind of pyramid. Lots and lots of unit tests at the bottom, lots and lots of small tests, not so many large tests at the top. If people haven't read this book, by the way, I suggest you go out and get it because it's fantastic. And it's essentially, as Mike Feathers describes it, it's the London School of Test-Driven Development. There's been a lot of talk about whether unit testing, if we're writing small microservices, which we can throw away or replace quickly, and I think my metric, or the metric we sort of agreed upon internally, is a service should be small enough that you can replace it within about 2 weeks. Should we still bother writing unit tests? Should we still bother with test-driven development at all? Right? This is a question. I think opinion is massively divided on this, but I'm going to come out and say yes. Personally, I think that unit tests are a core part of what it means to write microservices. And the reason is because it's hard to test microservices with all their dependencies, as I sort of said. So if we don't have unit tests, how are we going to know whether our services, whether our code is functional? I mean, I was, as I said, very lucky. I worked at ThoughtWorks. There's a whole bunch of people I work with at ThoughtWorks who have been involved in the testing community over a number of years. So you might notice Dan North and Liz Keogh, BDD people, Nat Price and Steve Freeman, who wrote that book. And often, people who, like these, who are talking about unit testing and whether we should throw away test-driven development, my opinion, and it's only an opinion, is that they're coming from a position of expertise. So for me, things like TDD, verification is only a very small part of why I like writing my code test first. Most of the time, I should point out. Sometimes I don't, but most of the time. But the testing part of it has only ever been a small part. For me, it's always been about design, always. And some of these other things like Yagni and don't repeat yourself. I've always found that the code I write is so much cleaner if I write code test first, because code has to be cleaner. And this is something called the Dreyfus model of skill acquisition. Maybe I'm up on the proficient end of the Dreyfus model. So the Dreyfus model is about how we acquire skills as individuals over time. And you progress, you start off as a beginner, you progress through advanced beginner to competency, and then you progress into proficiency and expertise. And proficiency and expertise are essentially at the point where you've internalized a particular skill. And I'd say maybe I've internalized how to write code such that it looks like I wrote it test first, even if I haven't written it test first. Because the point with writing tests, or writing your code test first for me, is that your code looks a particular way. You end up with really small classes. You end up with really small methods. Code that only does one thing, follows the single responsibility principle. And so sometimes when I don't write code test first, that's okay, because my code still looks like that. It still looks as if I had. But that's kind of because I've internalized these practices. And a lot of the people, I honestly think a lot of the folk who are talking about not writing unit tests or not using TDD at the moment, is TDD dead and all this, are in the same position. They've internalized this ability to write code that looks as if almost you had written tests beforehand already. But we do have this problem with microservices again, where we want to be able to test these things in isolation. And as I say, that's another reason I think that we should absolutely write unit tests. I think it's more important, essentially, than it's ever been. So the next one, SRP, single responsibility principle. So this is a former colleague of mine, Alistair Jones. This is a restatement. The original statement is an object or a method should have a single reason to change. This is a restatement, which is a class should be no bigger than my head. And this is Alistair measuring whether a class, this is in the Neo4j code base, is too big. I think he's worked out in this case it's fine. What do I mean by that? Again, back to this idea of chunking up and chunking down. As we chunk up from an object to a group of objects in a service, a group of objects that are sending messages to one another in a service. Each of these should have a single responsibility, and the service should have a single responsibility. As we group up to the level of a set of services communicating, they should have a single responsibility, a single reason to change. But also, I should be able to understand them in their entirety. I should be able to understand every single thing that a service, or an object, a service, and a group of services is doing. So it's a restatement of the single responsibility principle. It's turtles all the way down. We can apply this at the level of object, at the level of microservice, and at the level of capability. So objects should be no bigger than my head. The next one is KISS. Keep it simple, stupid. The next one I'm going to talk about. This is, it's a bit offensive, really, but it's another one of these mantras that we have, that sort of extreme programming community is fond of. Keep it simple. And when I was thinking about this is from our Tech Radar, the most recent Tech Radar. In this we've got, back one. In this we've got application servers on hold, right? And I think this is a function of applying KISS. So ThoughtWorks as a group have sort of come out publicly and said we don't think it's worth using application servers anymore. Use embedded servers. Use simple, lightweight, embedded servers instead of application servers. Because essentially, we don't need application servers anymore, right? They're too complex for our needs these days. They're too complex, they're too heavyweight, they make testing difficult, they make deployment difficult, and they slow our builds down. So why would we be using application servers when we've got so many other tools that we can use? This is an example of keeping things simple, and this kind of runs through the DNA at ThoughtWorks. And when I think about KISS, I often ask myself, this is how I think about KISS, what would Joe do? This is what WWJD means, and I don't expect you to know who Joe is, so I might just explain. Joe Warnes is a software developer who worked at ThoughtWorks, is now living in Chicago, and he's got this amazing knack for finding simple solutions to complex problems. It helps that he's one of these sort of mythical 10 times productivity people. There's a joke about Joe actually being a code word for a team of 10 people. What would Joe do, I ask myself? And this is an example of what Joe would do when he's writing code. So Joe, when faced with a problem, doesn't think, I'll go off and find and use whatever's there. He thinks, what's the simplest thing I can possibly do? In the case of needing a HTTP server, I think in this case it was for WebSocket support, he didn't like trawl around looking for HTTP server, so big pieces of big application servers that could do this. He just thought, I'll just write my own. How complicated can it be? And did. And it's really small, really, really fast. It's called Webbit. It's on GitHub. It's pretty cool. What would Joe do? Joe would try and find the simplest possible solution. And this applies in the microservices world, and there's an example of this applying in the microservices world. I was on a project fairly recently, well, last year. I rolled off October last year. And we were looking to implement monitoring across our system estate. We had probably 10 or 15, can't remember exactly, microservices, and we were looking to implement monitoring. And we knew we were going to eventually, over time, stand up a big StatsD infrastructure that would support StatsD. We were going to have console.io running. We were going to have a bunch of other tooling that were going to support monitoring and health checks and status and service registries. We'd have a bunch of these tools. But in the meantime, we just needed something, right? And rather than spend a long period of time trying to implement all this stuff or waiting without anything, we came up with this thing. So this is a really simple visualization of what our microservice infrastructure looked like, built in about 2 days using Python, essentially. Keep it simple. Sometimes the simplest thing you can do, even if it's not something that is going to be workable in the long term, is able to solve specific problems in the short term. And that's a blue-green deploy happening. So this is just querying the Amazon APIs. It's pretty simple. So that's the thing about KISS. KISS still applies. Do the simplest possible thing. I've started off talking about integration and deployment. We've covered off a few of the other sort of tools in our toolbox. Maybe I'll talk about some of the patterns that we can use with microservices to help us with integration and end-to-end testing and so on. So the first thing is semantic monitoring. Rather than run our tests in an integration environment to check our software is all working, we can just push our services straight through into production and rely on testing in production, essentially. This is something called semantic monitoring. There's another approach we can take. There's another approach we can take which is called another practice, and that's of writing contracts for our services. So each service consumer writes a contract and gives it to the service itself, who execute that contract as part of their build. Coming back to the test pyramid, one of the reason we want tests, or one of the reasons we want tests in this sort of format, fewer large tests, many more small tests, is that we get faster feedback the further down the pyramid we go. If we can put contracts or executable specifications, essentially, of how our services should behave as written by the clients into our build pipelines, then we can get fast feedback as to whether we've broken anything when we've changed code. So we can write these consumer-driven contracts and put them into our build pipelines. And they're pretty straightforward, and they've been around for the best part of a decade now. So the way you use consumer-driven contracts is I'm the consumer of a particular service. I'm going to specify how I expect that service to behave in an executable format, and then I'm going to give it to the service to run as part of the build pipeline. Pretty straightforward. And there's a bunch of tools to help us support this. This is an open source tool. It was a clean room implementation, I believe, of some tooling we developed on a project in Australia, Pact. So it's in Ruby. You can write your executable expectations, and then you can run those, execute them as part of a build pipeline. Check the time. Ooh, 6 minutes. I've got another 200 slides. I hope you don't mind. The next thing is this idea of testing in production. I mentioned this briefly, but this is the idea that we're just going to do away with integration environments altogether. We're going to push our code all the way from our workstation, potentially automatically all the way through into production, and test it there. Now that relies on a couple of things. It relies on having things like consumer-driven contracts, potentially. It relies on having things like semantic monitoring. And it relies on us knowing whether we've broken something really, really, really quickly, essentially. I think Netflix have got a rule, they should know whether any particular service is down within 15 seconds. That's the sort of fidelity that we're looking for. We want to be able to understand whether our code or our services are broken within about 15 seconds. So if you can deploy something within 15 seconds, know that you've broken something, you're in a good place. But doing this means that you have to get really, really good at fixing problems quickly. So this is why this sort of thing is associated with the build it, run it model of organizing teams. So this is where teams are both writing the code, supporting it in production, to get really, really good at fixing it. If you've got a change control process, which means when you deploy, you have to hand over to a completely separate team, and they're going to deploy overnight and all this kind of thing, this is probably not going to work for you. As I say, do I really mean we should no longer bother with integration environments? Okay, so most organizations aren't in a position to go for this approach. It relies on a bunch of stuff around infrastructure automation, configuration as code, all these sorts of things. But a lot of the big organizations that are sort of driving the microservices style forwards are moving to this sort of model. And it's no coincidence, I think, that most of them are on elastic infrastructure. Because what that's given us over time is this switch between the idea of pushing code into production and your code being live. Right? If you're deploying into virtualized environments where you can just start up new versions of things, there is a difference between being in production, being in a production environment, in your production data center, production VPC, whatever it is, and actually having traffic routed to your service. And so a lot of organizations have sort of recognized this, and they realize that, hey, actually, I can just start up any new version I want. If our customers can't see it, if no users are actually getting access to it, where's the harm? And if I can do that, just start up a bunch of services in production, I can get our QAs to test it in production. I can get our product owners and product managers, the developers can have a look in production and make sure everything's working before redirecting traffic and making it live. I also mentioned this other problem at the start with versioning and evolution and so on. I'm just very quickly going to cover off a couple of small patterns around this. So, for me, the question about if I make a change to a service, maybe we're monitoring, we've got good monitoring in place, we can deploy directly into production and test in production, maybe do some A/B testing in production. If I'm a developer writing a service, what does it feel like? And I'm kind of thinking, I want to know what the blast radius of the change is. Who is going to be affected by a change I'm making in my software? And I think there's three different types of change. There's whether it's within a team, so whether it's myself sitting next to my colleague on the same team, whether it's between two different teams. So in the case of the retail and fulfillment thing, maybe it's the retail and fulfillment team, changes between those two teams, but then also between organizations. So there's these three different sort of blast radiuses of change of your services. And I think you can treat each of them separately. There's a great book from decades ago now. When is it? 1977. Yeah, it's pretty. I was 3 at that point when this book was written. And this is about how information flows within organizations. And this is a book, I think it was partly a PhD thesis. And in this book, there's a great graph which describes how communication tails off with distance between people. This is specifically in R&D environments. You can kind of see on this, at about 10 to 15 meters separation between individuals, the chance of a weekly ad hoc conversation about work, this is probability on the y-axis, pretty much is 0. And this reinforces this idea that there are these different change boundaries within organizations, different change boundaries for services, within a team, between teams, and externally. So what might we want to do given some of these patterns I've talked about, or techniques and tools? Well, the first one is if you're within a team, you might want to rely on serendipitous change. You might want to rely on this conversational change. Hey, Kate, I've changed my service. Can you just update yours? That kind of thing. But as you expand out to a larger blast radius, between teams, you might be applying different patterns. So you might be applying something like the tolerant reader pattern as well as conversational change. And as you expand out again between organizations, you might be thinking about different patterns again. So hopefully I've sort of given you some insight into what's been in my head the last few months. Do some of the patterns that we have apply. What got me thinking about this is working on a couple of teams last year where we were really struggling with deploying things independently, really struggling with how to integrate and do integration tests across sets of services. And as I say, as a community, as an industry, building out applications using the first post-DevOps architectural style, we're still learning how to do this. Fundamentally, we don't have all the answers yet as an industry as how to build microservices, how to test them, how to integrate them, how to deploy them. We're still learning. We're still learning how to build systems that last, right? That can be replaced, components of which can be replaced over time. And this stuff is hard. It's quite tricky. And that's why Martin Fowler wrote this great paper on you must be this tall to use microservices, because if you don't have a set of prerequisites in place, this stuff can be difficult. But at the same time, it's kind of exciting, right? We're all here, what is it, 2,000 people at this conference? So many new tools, so many new approaches. The singularity is approaching. Pace of change is getting faster and faster and faster. And that's exciting as software professionals. And it's also exciting that we've got this body of knowledge that we can apply. Things like single responsibility principle applies all the way up and down. Things like the grasp patterns. Time's up, which is handy, because I've got one slide left. We've also got a whole bunch of new patterns, and if you haven't come across some of this stuff before, I suggest you seek it out, learn a bit about it, and maybe see if you can apply it on your own projects. And on that bombshell, I'm going to say, do the simplest thing possible, and thank you very much. Bye-bye.